In this video, we will be using RICE or ICE to calculate equilibrium constant. So RICE stands for reaction initial change in equilibrium, and ICE is essentially the same thing except it's initial change equilibrium. So in our problem, we have a certain temperature. We have 0.75 moles of NH3 is placed in a 1.25 liter container. And so NH3 breaks down into N2 plus H2 essentially. At equilibrium, we have 0.105 moles of N2, and we want to know Kc. So let's get started. So first we will write down the equation. So we have 2NH3 would produce N2 plus 3H2. Next we write the initial amount, initial concentration. So we have 0.75 moles of NH3. So we write that down, 0.750 moles. And so initially we don't have any of N2 or H2. Next we need to do the change. So we have 0.105 moles of N2. So we say plus 0.105. This has a 3 in front, so we say 3 times 0.105. This has a 2 in front, so we say 2 times parentheses. Now this would be actually negative 0.105. It would be the opposite of the product. So negative 0.105. And so next we need to add it up. Add the equilibrium. So 0.750 minus 2 times 0.0105. We would get 0.50 moles. This would remain the same, 0.105 moles. Finally, 3 times 0.105 would be 0.315 moles. Next, we will find the molarity. So molarity is moles over liter, and our container is 1.25 liters. So now we will get the molarity of NH3, this one right here. So that's going to equal 0.540 moles divided by 1.25 liters. Next, N2 is equal to 0.105 moles divided by 1.25 liters. And finally, we have 0.315 moles divided by 1.25 liters. And this right here would be H2. And so this right here would equal 0.432 molar. This is equal to 0.084 molar. Finally, this right here would equal 0.252 molar. The next step is pretty simple. So we say Kc is equal to, so now we have N2 times, we have H2, so H2 raised to 3 divided by now NH3, so bracket NH3, close bracket, and then we square it because this has a 3 in the front, that's why we cube it. This has a 2 in the front, that's why we square it, and it's always the product over the reactant. And now we simply replace what we have. So N2 was 0.084, H2 was 0.252 raised to 3, and finally NH3 was 0.432, close bracket, and we square it, and so we would get 0.00720 as our final answer. And that's all we need to do for this problem.